This shows the Arctic. It shows the sea ice in 1979 versus 2005. Can you see the difference?
Yeah.
Especially over here, okay, that there's less ice now, and that is continuing each year, that the amount of sea ice is decreasing. The other thing is that what reflects sunlight, what color reflects sunlight?
White.
So as ice melts, what does the color turn from? White to dark blue. And what does the darker colors do? Absorb more of the sunlight, which causes more of the ice to melt, which means less reflection, which means, and then you have that cycle. This is a picture showing a glacier. Glaciers are sheets of ice covering land. In 1928, this picture of the glacier, you can see all of this land was completely covered by a sheet of ice, all the way up into the mountains. The same image from the exact same perspective in 2004 shows that this glacier has melted and receded all the way back up into the mountains here. And what's left? Land and lakes. So obviously, that's a major impact to species that depended on that ecosystem for their survival. Species that are adapted to those conditions cannot survive anymore. The last thing is, if this is sort of a scenario, it's extreme, but it's possible. If all of the ice were to melt, all the ice at the Arctic, Antarctic, and Greenland were to melt because the Earth warmed to that level, all of that water would go into the oceans, raising sea level a significant amount. This would show the coastline of the United States if that were to happen. Okay? All of this that's in blue is underwater. So the cities you see there are major cities: Miami, New Orleans, Savannah, Richmond, Washington, Philadelphia, New York, Boston. All of those cities are basically on the coast. That's where people settle, on coast. There's abundance of food, there's easy transportation, it's nice to look out at the ocean. So major cities throughout the world are on the coasts. And if they get flooded, that's a major impact. The other thing is island nations. This severely impacts. Obviously, they're right at sea level, and an increase in sea level will have major effects. Places like Indonesia, huge country with
Thousands of islands.
yeah, it's a whole nation made of many islands. And again, that's a nation that would be inundated with these waters if global warming continues. So there's a lot of consequences. And so how do we help this issue? There's really only one major thing you can do, is to reduce the amount of what? Fossil fuels we're burning, reduce the amount of carbon dioxide we're adding to the atmosphere. And that's difficult, because everybody still wants all their stuff. And we have not perfected other technologies for generating electricity and heat. Okay? Wind power is okay, there's not a ton of it. Photovoltaic, solar power's okay, but there's not a ton of it. Geothermal, hydroelectric, those are okay, but still nothing is able to take the place yet of fossil fuels.
I have two questions. Don't they just make the solar fuels black and then make it a lot more?
They are pretty dark, yeah.
And would putting ice in the water actually affect the sun and make less?
No, because it would take more energy to make ice, that you would then, making that energy, you have to use fossil fuels and produce CO2. So it's not a permanent solution to the problem that's we talked about. I mean,
In science last year, we had to do a project on fossil fuels and see like how much everyone used the cars every day, how much
oh yeah, that's cool.
gallons and
They have this neat thing where you can plug it into an outlet, and then you plug in whatever, your phone charger, your television into it, and it gives you a reading of how much energy it's using. Like, you know that even when, let's say, your phone charger, if it's plugged in but not actually attached to your phone, it's still using small amounts of electricity, even though nothing's plugged into it. They're sometimes called vampire appliances. So like your TV is using energy often, even though it's off. And so you could like measure those things using one of these. It's called a kilowatt. It tells you the amount of electricity you're using. See that? All right, our last thing here is, this is kind of, it's kind of added on. It's not an environmental problem or anything, it's just sort of a neat thing to talk about. I don't exactly know why we put it here at the end of the ecology, but it's, this is called tropisms. And tropisms are when plants move or grow in response to a stimulus. And there are different types of tropism. Some you're probably familiar with, some you may not be. I know you have an extra column. I was going to ask you to fill it out, but we're going to skip that. What do you think phototropism is when plant? Did you ever like bring your mom home like a Mother's Day plant from school in 3rd grade?
Yeah.
And she puts it in the window in a styrofoam cup,
Yeah.
and the bean plant grows or whatever. Which direction does it grow in when you put it on the windowsill?
To the window.
Towards the window. That's phototropism. Plants will naturally grow toward a source of light. What do you think hydrotropism is? Tom?
Towards water.
Yeah, they grow towards water, like the roots of a plant will grow towards a water supply. Chemotropism.
Like chemicals.
Chemicals. Plants will avoid certain chemicals in the soil. Thermo? Heat. Yes, is response to heat. Gravito. Gravity. You know, if you buy a tomato plant at the store, you put it in a big pot and plant it upside down with the roots up and all the leaves down buried in the soil. What will happen in a few days? Yeah, those leaves will then begin growing upward, away from the force of gravity. They'll pop through the soil eventually. And the roots will do the opposite.
That's cool.
Thigmotropism is a response to touch.
You have to cross out your hypothesis.
Yeah, that's fine. So a Venus flytrap, what kind of tropism do you think that is? Thigmo, that's touch. How about this plant growing towards this area of light? Photo. A vine grasping onto the side of a building. That's thigmo, it's touch. Or the plant sideways growing upward. Gravity. I have some neat videos to show you of some of these. They're time-lapse videos, sped up. This first one is a coleus plant. That's sideways. Which one is this? Gravitotropism. It's growing upward, opposite of the force of gravity pulling down on it. This one is called the sensitive plant. They hold a flame near it, and it reacts, and the leaf all closes up. What's that?
Is this some equipment or
How long does that take?
thermal?
Not that long.
Is this?
That's like that. That's thermo.
Why does it do that?
It's like as an adaptation to protect from fire. That if all your leaves sort of curl up, you're less likely to burn. What's this?
Venus
Venus flytrap.
Thigmo.
Now we're gonna watch a really cool video after this.
Yeah.
Do you know how it works? Like they're touching it all over the place. It's not closing.
It's once it gets to the middle, sort of.
There's
Is
6
that
hairs
actual
in there.
time?
Yeah, I know they were like.
And if something touches 2 of them within 20 seconds, that triggers it to close. This one,
The
photo. They're going towards light, and then the light turns on overhead, and they straighten up.
It's like ET.
This is a vine. Look how a climbing vine grows. It
In a
grows as
circle?
a spiraling pattern, and then eventually, once it comes into contact with a vertical surface, it starts to sort of grow around it. That's how like peas and beans and other winding plants.
Oh, so they like circle the vine. Well, that's cool. Ah, so they circle. It's turned rough.
Yep.
Anthony Capelli, as you can on our grade, he has like 12 Venus flytraps in his house.
Oh, really?
Oh, yeah.
Yeah, Venus